Okay. Now we're still in module. This is a last session in tutorial for module number 2, week number 6, and we're still working on DC-DC converter. He told me consider a step down DC-DC converter. Just 1 second. Okay, 1 second. Sorry. So we're still working on DC-DC converter, as you can see here. Consider step down DC-DC converter. So he told me step down. Directly understand this is a book converter. Consider all components to be ideal. This is our assumption as usual. He told me that the output voltage is given, frequency is given directly when he give me frequency. So directly I go for TS. Quick calculation. He told me that the inductance is given, capacitance is given, almost he gave me everything. What he asked me to find is delta VO. And he told me that VD input voltage is 12.6 and output voltage is this. He also asked me to find the mode. Is it continuous discontinuous mode or discontinuous conduction mode? So let me summarize the question. In this question, he asked me two things to calculate. One is the delta V, ripple in voltage. And two is the mode. Is it continuous and discontinuous conduction mode? Since it's book converter, let's assume that this is final year exam. Let's assume. I go for step down converter slides. I have all formula there. I go there, delta VO, which is what he asked me to calculate. I have the formula. Let me go through the formula, see what he gave me. He told me TS, I need TS. Okay, it's okay, I can calculate it. It's very simple. Reciprocal of frequency. Do I have C? Yes, he gave it me in the question. This is C. Where is C? This is C. Did he give me L? Yes, he gave me L. This is L. Did he give me TS? Again, I calculated. VO, is it there in the question? Yeah, he gave me VO. Where is VO? VO. This is VO. 5. What is left? D. Do I have formula for D? Yes, I have. This is book. So it's very easy. Output voltage over input voltage equal D. So I have both. V out, V input. This is output voltage. This is input voltage. Substitute, I got D. Now I have all elements. Just you substitute and do the math. Very simple. So start from the objectives. What is the objective of this equation? Delta VO. Go to the formula and see the items. Do you have all items? Substitute directly. If some item missed, search for information, take you to the item. This is the way. Now the second point is he asked me if it is continuous conduction mode or discontinuous conduction mode. Just let me remind you. What we discussed before. We said that we go to the boundary IL boundary condition. Okay? If the boundary, let's assume boundary condition found to be 10. If my current is 11 greater than 10, then this means continuous conduction mode. If it is lower than 10, discontinuous conduction mode. Sorry. Okay? So let me see. Boundary condition. IL boundary. I have formula. This is book. I have formula. Okay. I have D. I have TS. I calculate both. L is given in the question. VD, I have it. VO, I have all information are provided here. So I substituted. I got the boundary current to be 75 milliamp. Now he told me that the output current is 200 milliamp. Now you tell me, output current greater than boundary current or lower than boundary current? You tell me. This is a question I'm asking. Output current greater than boundary or lower than boundary? What do you think? Excellent. If it is greater than, so we are in continuous conduction mode. Agree with this?
Continuous.
Great. So it's continuous conduction mode. You see, I come here, I say tick, because I solved the delta VO, I solved Sometimes you are given more than one objective. You need to follow them. Okay, check them and don't miss your unknowns or objectives. Another problem here, the chopper below controls a DC machine with an armature inductance. Is DC chopper, okay, which is book converter. I will see the information first of all. He told me that it controlled DC machine with armature inductance. He gave me inductance. The armature resistance can be neglected, the resistance of the load. Armature current is given 5 amp, and FS frequency is given, so I can find TS. He calculated D for me. Great. He told me the output voltage is given to be 200. Calculate the input voltage. Just a minute. This is book converter. He told me book converter. I didn't put here. It's the same previous circuit. Book converter. Okay? So I know that book converter VO over VD, output over input, equal D. He gave me D. He gave me V output. Can I find VD? Yeah, it's just direct substitution. Direct substitution. I got it 250. Very simple, straightforward. I take the first part. I go to the second part. Find the ripple in armature current. You remember current, increase, decrease. You remember this? Current, we talk about it. This is the maximum, this is the minimum. Max, min. And ripple is between them here. Okay? The ripple between them. Between maximum and minimum. He told me, find the ripple. I will come, I will say, okay. We know the waveform. They are the waveform of the current voltage, VL, and current, IL. The same in the slide when we discuss it. Okay. Now, I know that this is VD. This is here the positive voltage, which is 50 volt. And this is here the negative voltage, which is minus 200. Now, you may say, okay, how I know the on time, T on, from here to here, how much is it? And from here to here, T off, how much is it? Let me take you back. Have a look. We have D. It's given to me. I know that T on equal DTS. We discussed this before. And T off equal 1 minus DTS. I have TS, I have D. Let's substitute to find them. I substituted. I find that this is T on and this is T off, which is from here to here, as you can see. When we sketch, we have the graph. It is in the slide, but we need to specify the values here. Okay? As example here, VD minus VO, 250 minus 250. And here is minus VO, which is minus 200. You have it as a simple in the slide, in the lecture. Put it as a number. Okay? And definitely from here to here is the total period of time. Now I want to calculate the ripple, delta I. Okay, L. I know that the voltage here, which is 50, over L, which is given in the question L, okay, times DTS, which is on time here, DTS. I have both. I have this one. I calculate them. I find them 6.66. This is delta IL. Now, if I divide it by 2, okay, because you remember I mentioned here, okay, part here is delta IL over 2 and part here is delta IL over 2. Then the current will be in this range, 3.3 minus 3.3. I take. Calculate the maximum and minimum value of armature current. By the way, when he say armature current, he's talking about output, because armature is connected on the output, on the V out and I out. Rather than I tell you as example VO, IO, I tell you V armature, I armature, V armature. Okay, it's application. Okay. Now he told me also that we have the current is 5 amp. Okay, it's 5 amp. Now 5 amp. Have a look at this here. This is the current 5 amp. Okay. The output current. Now, the output current here fluctuate from here to here is 3.33 half delta IL, and from here to here is 3.33, half of delta IL, half ripple. Okay. So if I add them here this way, have a look. I add and subtract. Add 3.3 and subtract 3.3. It's look like in this way. 1.67 the minimum, and the maximum 8.33. Still, delta IL is the same, which is 6.66. I take this one. Sketch the armature current and ID. Okay, I have them in the slide. Okay, armature current is clear, the same current here, as you can see here. I just discussed it. But diode current or supply current, just a minute. Let me sketch the circuit to remind you. The circuit was working in this way. Okay, switch, inductance, diode, capacitor, and the load. Okay. Now when the switch on, okay, current will follow through the inductance. When the switch off, energy in the inductance will rotate. Okay. So what he asked me to do here is sketch diode current. When a switch on, current follow here, diode will be open circuit. Diode will be open circuit. Okay, and vice versa. So part of the time, the current will follow through the inductance. Okay, and when the switch on, the current will go to zero. This is the supply current. It's not conducting all the time, just in on time here, on time. I advise always to write here the time for on and off and the total time, T on, T off. I'm not talking about exam because we mentioned for this that this next test we cannot give you a question related to graphs. Okay, to sketch a graph, you cannot. But maybe in the final you will have it. Okay, hopefully things will become better and you can come to the campus. Now last is still we have two points. The load on the machine is reduced. Calculate IA when the converter is on the boundary between continuous and discontinuous conduction mode. I will solve them together in one slide. And the load on the DC machine gives IA 2 ampere. The current now is discontinuous. It's go to the discontinuous. What is the back EMF? When it go to the discontinuous, let me start with this part. When it go to the discontinuous, then we go to the formula in the slide in the lecture related to the discontinuous conduction mode. Let me solve both. Now, first of all, we know that when the voltage is the same, You remember when I talk about IL boundary, okay? We know that it is TSD over 2L VD minus VO. You remember this formula. Since DTS, TS, and D and L is constant, but since the voltage did not change with the change, so still the current supposed to keep its value. It's not changed. If the output voltages change, at that time, change will occur to the boundary current. So we say it is not changed. For the back EMF, I have formula for the voltage in case of discontinuous conduction. He told me that the situation become discontinuous. You see here, discontinuous, and he gave me I armature, which is the output current. Now I say VD, I have it. Okay, I output, which is armature current, I have it. Inductance, he gave it to me. Time of the switching, he gave it to me. I substitute everywhere here. D, I have it. ILB max, sorry, I have it. What is left? The output voltage. I calculated. I cannot use V out over VD equal D because it is not anymore continuous conduction mode. It becomes discontinuous conduction mode. So I have to go for this equation. Okay. Now for the exercise, this is extra exercise. I picked it from previous years, let me say, exam and final. I gave you here the final answer. I advise you in next week to practice on it. Try to solve it. Okay. Take it as a practice for you and try to solve it. Now, Just 1 second.